All right, let's work out some polygons here. What do you guys say? All right, on this first one here, as always, we draw in our triangle. Remember, this angle is the 30, so this is equal, this is L, and this is L square root of 3. So if I do 4 square root of 3 over 3 times the square root of 3, then all of that cancels. That's going to be equal to 4. So this half is 4. That means my side length is 8, and the perimeter equals 24. So area equals 1/2 times 4 square root of 3 over 3 times 24. So that's going to give me an area of 16 square root of 3. Next problem. This is a septagon. It's got 7 sides. So if I draw in this side here, this angle is actually going to be 360 divided by 14, which is 25.7 degrees. So my side length here, I'm going to say tangent of 25.7 equals x over 14.4. So that's x equals tangent 25.7. And I'm going to try to flip and show you this on calculator as I do it. It's going to go quick though. All right, tangent 25.7 times 14.4 is 6.93. So this is equal to 6.93. So that means my side length is twice that. So 6.93 times 14 equals my perimeter times 14. 97.0, give or take. 97.0. So my area is 1/2 times 14.4 times that 97. So that gives me an area of times 14.4, whoops, 14.4 and then divided by 2. 698.6. 698.6. All right, number 3. This is just a simple octagon here. So for our octagon, we draw this in. We know this is 22.5. This is my x. So tangent of x over 14.5 equals 22.5. That winds up giving me an x of about 6. So my perimeter equals, 6 times 16, which is 96. Yes? No, 84. Sorry. 84. So the area is 1/2 times 14.5 times 84. All right, so let's make sure that that's what we get. I did 14.5 tangent 22.5. That's my x, about 6, times 16. That's my perimeter, about 96. And then times 14.5 and divide that by 2. That's going to give me 696.7. So this area is equal to 696.7. All right. Next one is a pentagon. In a pentagon, this is a 36-degree angle. So tangent of 36 equals x over 5.1. So that's going to give me an x of about 3.7 something. My area, my perimeter, is going to be 10 of those. So about 37 or so. So my area is 1/2 times 5.1 times 37, which is, and here we go, 5.1 tangent 36. That's half the side, so times 10. That's my perimeter times my apothem times 1/2 gives me an area of 94.5. 94.5. Next, we have a nanogon, 9 sides. So this angle, actually, let's draw this over here. This angle winds up being 360 divided by 18, which is 20 degrees. So here it's tangent 20 equals 16.5 over x. So x is going to be equal to about 6 again. My perimeter equals 6 times 18, which is about 108. So my area is 1/2 little a, 16.5, times the perimeter of 108. So area equals, and here we go. So I did 16.5, 16.5 tangent 20, which is about 6 times 18. That's my perimeter, about 108. Times the apothem, 16.5, and then divide that by 2. My area is 891.8. 891.8. All right, number 6. Here we go. This is a hexagon. So we know this is our 30-degree angle. So if this bit is 5 square root of 3, that means this is 5, and this is, of course, 10. So my perimeter here is just 5 times 12, which is 60. So my area equals 1/2 times 5 square root of 3 times 60. So half of 60 is 30. 30 times 5 is 150. So it's 150 square root of 3. Next, we have a pentagon that has an apothem of 7.3. So that's going to look like problem number 4. So here I go. I'm going to say tangent of 36 equals 7.3 over x. So my x, half of my side, is going to be about 5.3. The area equals, and so this side is 10.6. The area is 1/2 times our 7.3 apothem times 10.6 times 5. So let's get all that in. 7.3 tangent 36. 7.3 tangent 36 is that number times 2. That's our side length, 10.6, times 5, it's a pentagon, is our perimeter, times our apothem of 7.3, and then divide that by 2 times 1/2. So it gives us 193.6. 193.6. Here we have a triangle, just a simple triangle that has, oh, you know what? We can do this perfect one. We have a triangle that has an apothem of 14. All right, so remember, in our triangle, that's 2L, that's L. This is L square root 3, and this one is L. So my side length is 28 square root 3. My perimeter is 28 square root 3 times 3, which is 28 square root of 3 times 3. 28 times 3 is 84 square root of 3. So this is 84 square root 3. And so my area is equal to 1/2 times 14 times 84 square root 3, which is 588 square root 3. Okay, there's the whole front page. Let's move on to the back. Here we have a 7-gon, 7 sides. So remember, this angle is going to be equal to 360 divided by 14, which is about 25.7. So here I would say tangent of 25.7 equals x over 21.8. So my side length is going to be twice that. So here we go, 21.8 tangent of 360 divided by 18, that's just to give me the exact number, is 7.93. So my side length is going to be twice that, yes. So 21.8, yeah. So my side length is, did I do that right? 21.8 tangent 360 divided by 18, yeah. Because 360 divided by 18 is 20. Oh, I did that wrong, sorry. So it's 21.8 tangent of, 360 divided by 14. which is 10.49. So multiply that times 2. My side length is about 21. All right. So yeah, about 14. So my side length, this is about 10.5. This is about 21. So area equals 1/2 times the apothem of 21.8 times the perimeter, which is 21 times 7. That's a 1. 21 times 7. So here we go, multiplying that number times 7 times my apothem of 21.8 times 1/2 gives me an area of 1602.0. 1602.0. All right, number 10. Now we've got an octagon, so remember the angle that we're dealing with an octagon is 22.5 degrees. So I'm going to say tangent of 22.5 equals x over 14.1. So my side length, my x is equal to 14.1 tangent 22.5, 14.1 tangent, clear, 14.1 tangent 22.5, which is that number, times 2 is the side length, 11.7. So this was half of that, which was 5.85, 5.8. 5.8. So my area equals 1/2 times the apothem of 14.1 times 11.7 times 8. So let's see, we're going to take 11.7 times 8, clear, times 8 times my apothem of 14.1, and then times 1/2 gives me 658.8. 658.8. All right, now answers in simplest form. Number 11, I've got a radius of 18 on this triangle. So I know that this part is going to be, this is 2L, this is L. So this is going to be equal to 9, and this is 9 square root of 3. So my side length is 18 square root of 3. 18 times 3 is 54. So it's 1/2 times 9 times 54 square root 3. So that is going to wind up being 243 square root 3. All right. Hexagon. I've got 4 square root of 3, so this side length is 4. This is 2L, this is L, and this is L square root of 3. So this one's easy. 4 times 2 times 6 is 8 times 6, which is 48. So my area equals 1/2 of the apothem, 4 square root of 3 times 48. So that's 2 times 48. This is 96 square root 3. Here I've got an equilateral triangle that's 10. I could go the apothem route, or you know what? I could just say, hey, I divide this guy in 2. I know this is a 30, 60, 90. This is 5. This is 5 square root of 3. So area equals 1/2 base times height in this case. So 1/2 the base of 10 times the height of 5 square root of 3. It's going to give me 25 square root 3. And here on this last one, I've got a radius of 8. All right, so this is 2L, this is L, and this is L square root of 3. So L is going to be equal to 4. This is going to be 4 square root of 3, which is the exact same answer as number 12. Because this one has the apothem of 4 square root of 3, this one has 4 square root of 3. So that's 96 square root of 3. Booyakasha. A quadrilateral, which is just a square. All right, hang on, we can do this better. This is a square, and it has a radius of, whoops, not quite that far. A radius, nope, there we go. A radius of 16 square root 2. That means this part is 16. So that means each side is 32. So my area equals 1/2 times 16 times 32 times 4, which is equal to 1,024. A hexagon that has a side length of 16 square root of 3 over 3. Well, I know if I draw in my triangle, That means this is going to be 8 square root of 3 over 3, 2L, L, and this is L squared of 3. So I'm going to take 8 square root of 3 over 3, multiply it times square root of 3. This is 3, so all of this cancels. So that's going to be equal to 8. So that side length is 8. That's the apothem, in case you couldn't figure that out. This is half the side length. This is the apothem. So my area is equal to 1/2 times 8 times 8 square root of 3 over 3, and there are 6 of those. So all of that is going to be equal to 128 square root 3. All right, find the perimeter of a regular hexagon that has an area of 54 square root of 3 units. Wow, how interesting. So let's think about it. The area is 54 square root of 3 units. Well, I know that if I draw a hexagon, all right, let's suppose we know this is a 30, 60, 90 triangle in here, right? So if this bit, this is going to be, if this is A, then actually, yeah, let's think of it another way. This number right here is P over 12, right? But that P over 12 is also equal to L. So this part right here in my 30, 60, 90 triangle, this is P over 12, which is equal to L. This is L squared of 3. So if L is equal to P over 12, then L squared of 3 is equal to P square root of 3 over 12. So that is always the relationship between the apothem and the perimeter. The apothem is always equal to P squared of 3 over 12. So I know my area equals 1/2 little a P. But little a I've got right here, so I can say this is 1/2 times P square root of 3 over 12 times P. Oh my gosh, so confusing. Now this is going to be 54 square root 3. So now I just got to solve this for P. It's going to wind up being something squared. You know what, you guys? It's going to be difficult. Once you get from here, I don't have the paper to show it out, but that's the key bit right there. Eventually the perimeter becomes 36. You can do it by guess and check as well. Can a regular octagon have an area of 10 units squared? Heck yeah, why not? It just wouldn't have, yes. It just wouldn't have no regular, no integers for side lengths. All right. And that's the solutions on the homework. Enjoy it. Have a great day with the sub.